Today I'm going to do a geologic geometry question from the higher level DCG paper from 2019. The accompanying map located on the back of the page of section A shows ground contours at 5 meter vertical intervals. ABC is the centre line of a proposed track for the motocross bikes. DEFG is the proposed pit stop area. O is the centre of the circular curve. The track has the following specifications. The portion from A to B is level at an altitude of 55. The portion from B to C is uniformly rising to a level of 60 metres at the finish line C. The formation level at F in the pit stop area is 55 metres and has a gradient from F to E in the same as that of the track from B to C. Using side slopes of 1:1 for the cuttings and 1:2 for the embankments, complete the earthworks necessary to accommodate the track and pit stop area between A and C on each side. So I'm going to start with part A. So the first thing I'm going to do is just highlight the different things. So from A to B it's level at an altitude of 55. Rising uniformly to an altitude of 60 at C. F has the same altitude, and then E has the same altitude as C. Okay. Now, when the road is level, what I like to do is identify where the 55 meter contour is, so where it's going to meet the road. So it's going to meet it right there. So the first thing I'm going to do then is write out my cut and fill ratio. So the cut ratio is 1:1. So that means that we're going to be going 5 millimeters with the intervals. And then over here, then the fill ratio is 1:2, which means they're going to be 10 millimeters apart. Okay, because I need to multiply my ratio by my 5 meter vertical interval. So I can see then these contour lines on the map are less than 55, so that means I need to fill up towards 55, and then after this one then they're greater than 55, so I need to cut away. So I'm going to be going 10 millimeters here and then 5 millimeters above that. Okay, from B to C now, that is a curve and the center of that is at point O, so I'm going to have to use that point. So the first thing I'm going to do is just out from O, I'm going to draw a line. So join up your points where they cross each contour line. So because then we're filling up towards the road, then our earthworms go inwards. Okay, last part then is from here over to B, and that is cutting away. So that's only 5 millimeters apart. Okay, so the second part then says the portion from B to C is rising uniformly to a level of 60 meters at the finish line C. Okay. Now, when the road is rising or falling, you're going to have a cut cone or a fill cone, and we need to work out the radius of both of these cones now. Okay, so to get the radius of your cones, it's the difference in height, which is 5. Okay, so from 55 meters to 60 meters, the difference is 5. Multiply that then by your ratio. Radius 5, and that's going to be radius 10. Okay, the cut cone always goes at the low side of the road, and the fill cone always goes at the high side. Okay, so from B to C now we need to look at our contours. So these contours here are all less than 55. Okay, so we're going to be using the fill cone to fill up to that height. So we're going to be using a fill cone of radius 10 and it has to go at the high side of the roadway. So this is the low side because it's 55 meters. This is the high side, which is 60 meters. So we're going to draw a cone, okay, at point C and has a radius of 10. Now you draw it at the edge of the roadway at point C, and it's actually only a semicone that we need to draw, so a plan view of the semicone, which is just a semicircle. Okay. Now, if I join that then back to B, so the top of the cone have a tangential to B. The height of that line then is 55 because that line starts at B, okay, which is at a height of 55. Now, for our fill interval, it's 10 millimeters. So now what I need to do now is put more lines in that are 10 millimeters apart parallel to this line. So then identify on your contours where each cross the line. So it's important to understand that the fill cone always goes to the high side of the roadway and the cut cone always goes to the low side of the roadway. Because the road is rising, the fill cone goes at this side. If the road was falling, the fill cone will go at that side and the cut cone will go at this side. So it depends on the situation at hand. Then it says the formation level at F in the pit stop area is 55 meters and the gradient from F to E is the same as from the track from B to C. Okay, so from here to here now is rising as well to a height of 60. So what I'm going to do now is put in another semicone at point E. Draw a line from point F through that, and that has a height of 55. Then draw lines 10 millimeters apart. So again, identify then on your contour map where each one is. Join up your points. Now you can see that we still haven't touched the roadway, so what we need to do now is underneath this line we need to put in a 60-meter contour. You can see then that that meets right at the roadway at point E. Now the final part we have to do then is the part from B to F. So B to F has its level at 55. Now if we look around there, the contours from that are all less than 55. Okay, so we need to fill up that roadway. So this part is level, so we're just going to be drawing lines now 10 millimeters apart, parallel to the line from B to F. Now, where the two curves intersect, you join that then back to the turn in the road or the corner of your roadway. Okay, so that is the road geometry part of the question done. So now we're going to go into the mining geometry part of the question, part B. So it says on the map, P, Q and R are 3 points on the top surface of the stratum of ore. Q and R are the altitudes at 40 meters and 25 meters respectively. So Q is 40 and then R is 25. The stratum has a strike of north 54 degrees west as indicated by the strike line. Okay, so there's your strike. Using the X1, Y1 line already drawn on the map, determine the dip of the strike. So we already know that if you look along the strike line, you will get the dip or the angle of the stratum of ore underneath the ground. So what we're going to do is we're going to project out a view this way, set it up here in our X1, Y1 line, and that'll give us the angle to the horizontal plane. Now we're going to say point R, 25 meters. We're going to put that on the X1, Y1 line. So that's going to be a datum at 25 meters. That's point R. Now from that then we need to go up another 15 to get point Q. because 25 and 15 is 40. So there's point Q. Now we don't have a height for point P yet, but if we just join the two of them points together and continue out a straight line, that will give us the angle that our top surface of our stratum of ore is at. And we're going to measure that angle. So 39 degrees. Okay, so that's our angle. Now, part 2 then says, find the altitude of P in the space provided at the top of the map. Draw the elevation of the triangular portion of the top surface of the stratum. Point R is already located for you in the elevation. So now we need to draw an elevation of that stratum of ore. We have the height of R, which is 25 meters. We have the height of Q, which is 40 meters. We still don't have the height of P, but that's what we need to work out. So the first thing I'm going to do is draw my point Q and my point P, and then I'm going to go up in 5 meter vertical intervals. Okay, so to find Q, then we need to go up to the 40 meter line, and there's point Q. Okay, so we had our auxiliary elevation view here. We said that the x1, y1 line was at a height of 25 meters. So if I measure that distance from there to there and add on 25, that'll give me the height of point P. Because when I bring out point P from my plan view, there's where the two of them cross there, so that must be point P. So when I measure that, I get 40. 40 plus 25 gives me a height of 65. Just need to go up to 65 on my contour map. And there's point P. Okay. Now the last part then is to determine the true angle between the line PR and the strike line S. Okay, so the true angle they want between this strike line here and this line PR. Now, to get that, we need to be looking directly onto the top surface of the stratum of ore. So there's a couple of ways you can do this. The easiest way to do this is if we look perpendicular to the edge view of the top surface of the stratum of ore that we already have, draw an auxiliary plan view, and then take our measurements from our previous XY line back to our plan view. So we'll print a datum for that. That's x2, y2. And that's our datum line. So point P is on our datum line. So here's point P. And then we're going to measure up the height of Q and R. Join up your 3 points, and then there's your strike line there. The final thing now that we need to do is we need to measure the angle between our strike line and between our line PR. So I'll get an angle of 108 degrees. So I'm after getting an angle here now of 108 degrees. So if I measured that on the other side, it would give me it would still be the correct answer of 72 degrees. So it doesn't matter what side that you indicate the true angle at. So that is the 2019 higher level geologic geometry question done. And I hope it helped you doing the question.